Zero-copy cloning is a database technology that creates instant replicas of tables, schemas, or entire databases without physically duplicating the data. Instead of copying gigabytes or terabytes, it uses metadata pointers and a copy-on-write mechanism. This means the clone shares the original data's storage until you start making changes to the clone. It's like creating a shortcut to a file rather than making a whole new copy. Zero-copy cloning works through a sophisticated metadata layer that acts as a map, tracking pointers to the original data blocks instead of copying them directly. This layer allows instant creation of clones without duplicating the underlying storage. The key innovation is copy-on-write. When you modify data in the clone, only those specific blocks are duplicated at that moment. The original data remains completely untouched, ensuring perfect isolation between the original and its clone. By sharing the vast majority of data blocks between original and clone, zero-copy cloning eliminates redundant storage and reduces input-output operations. This results in massive cost savings and dramatically faster performance for development and testing environments. Zero-copy cloning provides three major advantages. First, speed. Clones can be created in seconds or minutes instead of hours. Second, cost efficiency. Storage savings can be significant, often in the range of 50 to 90% by avoiding redundant data. Third, isolation. Supports parallel development environments without interference, which is crucial for CI/CD pipelines. These three benefits, speed, cost efficiency, and isolation, make zero-copy cloning essential for modern data workflows. Platforms like Snowflake pioneered zero-copy cloning and have expanded its capabilities. Snowflake's instant cloning, introduced in 2023, allows cloning across hybrid and multi-cloud setups such as AWS, Azure, and GCP. In 2024, they added AI-optimized cloning, which reduces latency by up to 40% for large datasets. By 2025, Snowflake integrates with tools like dbt and Apache Airflow for automated environment provisioning. Other platforms like Google BigQuery incorporate similar features. BigQuery Flex slots, introduced in 2024, enable on-demand cloning with flexible resource allocation. This supports quick deployment and a pay-as-you-go pricing model. Databricks enhanced Delta Lake in 2025 with zero-copy capabilities for real-time analytics. This integrates with existing data lakes like Hadoop HDFS, Azure Data Lake Storage, and Amazon S3, supporting streaming and batch data pipelines. These platforms use zero-copy cloning to provide faster data access, testing, and development environments. Many companies have successfully implemented zero-copy cloning to transform their data operations. Let's explore some real-world examples. Walmart leveraged zero-copy cloning to create over 500 development environments for their data lake. This reduced provisioning time from days to minutes, enabling rapid A/B testing for personalized recommendations and saving $2 million annually in storage costs. Robinhood used Databricks Delta Lake cloning for risk modeling, cloning multi-terabyte datasets instantly for backtesting algorithms. This cut development cycles by 70% and improved model accuracy. A pharmaceutical company like Pfizer utilized BigQuery's cloning for clinical trial data analysis, isolating environments for GDPR-compliant testing. The clones handled petabyte-scale data without duplication, accelerating drug discovery timelines by 40%. The future of zero-copy cloning involves integration with AI to automate clone management and optimize for workloads like machine learning. There's also a growing emphasis on seamless cloning across multiple clouds to avoid vendor lock-in. This aligns with the increasing adoption of multi-cloud strategies by enterprises. Platforms are embedding AI to automate clone management, predict usage patterns, and optimize resources for machine learning training sets. This reduces manual effort and improves efficiency. This architecture, with metadata pointers and copy-on-write, supports AI-driven optimizations. There's a growing emphasis on seamless cloning across multiple clouds to avoid vendor lock-in. This aligns with the increasing adoption of multi-cloud strategies by enterprises, with 60% expected by 2025, according to IDC. As shown in this chart, adoption rates for multiple cloud providers increase with company size, highlighting the importance of multi-cloud capabilities. Looking ahead, zero-copy cloning is poised for significant expansion beyond its current applications in cloud data platforms. One key advancement will be the incorporation of quantum-resistant encryption. As quantum computing threatens traditional encryption methods, zero-copy cloning will adopt post-quantum cryptographic algorithms to ensure clones remain secure in decentralized systems. Federated learning will allow zero-copy cloning to support decentralized systems, where data remains on local devices or servers while models are trained collaboratively, enhancing privacy and security. Experts predict expansion to edge computing for IoT data. Zero-copy cloning will enable instant replication of datasets at the network edge, facilitating real-time processing of sensor data from devices like smart meters and vehicles. The technology will even find applications beyond databases, extending to file systems where zero-copy mechanisms can create instant snapshots of files or directories without data duplication. As the technology matures, zero-copy cloning will continue to improve, better handling massive datasets at scale and serving the evolving demands of industries focused on real-time analytics and AI-driven insights. While zero-copy cloning offers significant advantages, it's important to recognize that it's not without challenges. Organizations must address several key considerations to ensure successful implementation. First, handling encrypted data can be complex. The metadata pointers used in cloning may not seamlessly work with encrypted storage, requiring additional decryption steps or specialized handling. Regulatory compliance is another major concern. Standards like GDPR require strict data protection and privacy controls. Zero-copy clones must maintain compliance without creating unauthorized data copies. Governance is crucial to prevent data sprawl. Without proper oversight, the ease of creating clones can lead to excessive data duplication and management complexity. Managing access controls is essential. This matrix shows how permissions are assigned to different users and roles for various database objects, ensuring only authorized access to cloned data. Scaling for exabyte-scale datasets presents technical challenges as the metadata management becomes more complex. Balancing performance with security is an ongoing challenge. While cloning is fast, ensuring data isolation and protection against breaches requires continuous monitoring. Finally, as a relatively new technology, zero-copy cloning needs careful monitoring and management to remain both secure and cost-efficient over time.